Hi, I'm Chaitra. I'm a data engineering fellow at Insight. My project is called Event-Fluence, which can be used to determine the influencing power of credible tweeters. A lot of events are happening around the world. A credible source to get details for these events is GDELT. GDELT is an open source project that monitors various broadcast, print, and web news from around the globe and identifies event types, sources, actors, locations, etc. Each event information has all news links that have any mention of the event. So this is a sample to explain what GTEL data looks like. This is from March 3rd, 2020, when the COVID outbreak had just started. The first link is about the health officials warning people to cancel vacations. Second link has information about cruise industry being unhappy with the warnings. Both the links are related to the same event and have the mention of this particular event, which is the warnings by health officials to cancel vacations. This is how we can get all news links related to a certain event from GTELT. Now, going on to Twitter, a lot of Twitter users tweet news links. We collect these tweets that have linked to any of these events from GTELT and collect further information about those tweets like retweets, likes, etc., and use this to determine the influencing power of a Twitter user. This can be used by ad companies to target their ads based on who is interested in what. One example is based on what political news someone has tweeted. Political ads can be targeted towards those tweeters and their followers to influence their votes. We could use hashtags provided by Twitter, but sometimes multiple types of events have same hashtag and can cause confusions. But news links provide accurate information. Moving on to the pipeline architecture, we load the data from GDELT and Twitter to Amazon S3, prepare, clean, and process the data using Apache Spark, and then load it to PostgreSQL, and finally visualize the results using Tableau. This is the data model for Event-Fluence. Here we have the URL for tweets, and here we have the URL for event mentions. By combining these two, we get the dashboard we are about to see now. So this is the Event-Fluence dashboard showing analysis for March 2nd to March 9th, 2020. The first chart shows the number of tweets each day, containing links to news articles. The second chart shows the number of tweets for each event type like government, education, etc. This chart shows the top tweeters and their influencing power in each event type. This shows the top tweeted links. And this final chart here shows the top websites whose links were tweeted the most. So engineering challenges mainly was caused by the huge amount of Twitter data. So 1 month of uncompressed Twitter data is around 840 GB and is in JSON format. GDELT has around 18 GB of data, and we have two types of CSV files for it. One is for events, another for event mentions. So I started initially with 4 Spark workers, and in the first approach, I joined tweets with GTEL data to get the tweets with news links from GTEL. The idea was that the number of tweets with news links is less, so store only those in the database, but it took more than 15 hours. Next, I created 3 separate pipelines, one for Twitter, which took 12 hours to complete, one for events from GDEL, which took around 15 minutes, one for event mentions from GTEL, which took around 25 minutes. In this approach, what I did was did some Spark tuning and horizontal scaling, and the number of Spark workers was increased from 4 to 7. Twitter took 8 hours, GDELT took events took 8 minutes, and event mentions took 10 minutes. So since the GDEL processing time looked good in the third approach, for the final approach I used only Twitter data, and the data was processed in smaller batch of 10 days instead of one whole month. Each batch of 10 days took around 1 hour to complete, and therefore the total time to process a month's data was reduced to 3.2 hours. So UI queries were slow because of the joins and aggregations, and indexes were, I had to create indexes on status ID, URL, and other columns used for the UI queries, and then the queries return the data in less than a couple of seconds. So, this is me. I'm Chaitra, and I worked as a business intelligence engineer for close to 5 years. I have a master's in software engineering from San Jose State University. I'm a curious person, and learning something every day satisfies my curiosity. With data, you are never done learning. There is always something more to learn. And also, I'm excited about data engineering because oh, data empowers people to make informed decisions, gives us insight into the data, and therefore it helps us in creating a better world. And I want to be part of this empowerment. And data allows us to answer specific questions and make justifiable decisions that have a higher likelihood of success. My hobbies include reading, hiking, and cooking, and that's about me. Thank you.